CXMT has about 8% of global DRAM revenue, and it may already be changing Samsung's market economics. During this year's shortage, Reuters found China's memory champion charging more than Samsung for comparable server memory. If that scale keeps rising, DRAM stops being a three-company game. So how real is the threat? If CXMT is still far smaller, what exactly has changed enough to make this a structural story? To answer that, forget the simple story that China wins by selling cheaper chips. We need to separate four things: market share, manufacturing capacity, product quality, and customer qualification. CXMT is advancing quickly in some of them and still years behind in others. By the end, we will have a cleaner test for whether Samsung is facing a temporary shortage rival or a structural fourth force in DRAM. Start with the simplest question. How big is the gap today? Start with the market today. TrendForce says global DRAM revenue reached $97 billion in the first quarter of 2026. Samsung alone captured 38.5%. SK Hynix had 28.8%. Micron had 22.4%. Those three still control almost 90% of revenue. On the surface, that looks like an oligopoly with no room for a challenger. So why is an 8% player suddenly worth watching? But CXMT is no longer a rounding error. Counterpoint estimates its DRAM revenue share rose from 3% in the first quarter of 2025 to 8% 1 year later. Its prospectus puts 2025 share at about 7.7%. First quarter 2026 revenue jumped 719% year-over-year to 50.8 billion yuan, even with a booming price cycle doing part of the work. Growth in revenue is one thing. What is happening to physical capacity? Now look at physical scale. Reuters reports CXMT already runs two 12-inch DRAM fabs in Hefei and one in Beijing, each around 100,000 wafers per month. New projects in Shanghai, Hefei, and potentially Beijing could push total capacity above 600,000 wafers per month. That does not guarantee sellable chips, but it changes the size of the question. Why expand this aggressively now, rather than 2 years ago? Why is CXMT getting this opening now? Because the entire memory market is unusually tight. TrendForce says conventional DRAM contract prices rose roughly 93 to 98% quarter-over-quarter in early 2026. AI demand is expanding from HBM into general-purpose servers and high-capacity RDIMMs. When buyers are fighting for allocation, a supplier that used to be optional can suddenly become strategically necessary. But scarcity alone does not explain why CXMT is taking share in specific categories. The second tailwind is product mix. Samsung, SK Hynix, and Micron are pushing capacity toward higher-priced server and AI products. That leaves shortages in consumer and mature DRAM. TrendForce says CXMT used LPDDR4X strength to establish a four-player structure in mobile memory and is expanding server DRAM for Chinese cloud customers. The incumbents are moving up the value curve. CXMT is entering through the space they leave behind. The opening is real. The hidden question is whether CXMT can keep it when scarcity fades. That bullish case sounds powerful. But timing matters. TrendForce now expects mobile DRAM price increases to narrow to roughly 8 to 13% in the third quarter as consumer demand weakens. CXMT must turn shortage-driven opportunity into durable qualification before the cycle normalizes. A fab can be built and a wafer processed. Neither guarantees high-yield, reliable server-grade parts or approval from global customers. What is the first measurable sign that this qualification story is more than theory? Here is the first crack in the old market structure. Reuters reported that in recent weeks CXMT charged more than Samsung's roughly $1,240 price for comparable 64GB DDR5 server modules in China. That does not prove CXMT has superior technology. It proves something more immediate. During a shortage, some customers no longer treat Chinese DRAM as the automatic discount option. Pricing power matters only if customers are actually willing to qualify and buy the parts. And customer behavior is changing. Reuters reported multi-billion-dollar supply agreements with ByteDance and Tencent based on people familiar with the deals. Separately, HP, Dell, Acer, and ASUS have been evaluating or considering CXMT memory as supply tightness raises costs. Those reports are not the same as broad global adoption. but they show the qualification funnel moving from theory into real procurement decisions. A new supplier does more than take units. It can change how the entire cycle behaves. Why does that matter for Samsung? DRAM profits depend on more than market share. They depend on supply discipline. Three dominant producers can respond to weak pricing by cutting investment, shifting product mix, or slowing wafer growth. A state-backed fourth producer with fresh IPO capital and strategic reasons to expand may behave differently. Even if CXMT never becomes number one, it could make the next commodity down cycle harder to control. But before calling this a war, we need to identify the bottleneck CXMT still has not solved. But this is where the title needs discipline. CXMT is not yet matching Samsung at the most advanced end of memory. Reuters says it remains behind in HBM, and sources described a gap of roughly 2 generations. Export controls also restrict access to advanced manufacturing tools. So, the hidden bottleneck is not money or factory shells. It is converting capital into leading-edge, high-yield, qualified memory at scale. So what converts a fab from an impressive asset into a competitive weapon? Memory manufacturing has 3 brutal filters. First, can the process print the design consistently? Second, can enough dies pass electrical and reliability tests to make the wafer economic? Third, can the product pass a customer's qualification for servers, PCs, or phones? That is why announced wafer capacity is not the same as competitive capacity. The only capacity that pressures Samsung is capacity that produces qualified bits customers will actually buy. That mechanism gives us a better way to measure power than headlines about fab count. Here is a useful model. The 3 gates of DRAM power. Gate 1 is wafers. How much physical capacity exists? Gate 2 is qualified bits. How much good output survives yield and reliability? Gate 3 is customer access. Who is willing and allowed to buy it? CXMT is clearly advancing through Gate 1. The real battle with Samsung is whether it can pass Gates 2 and 3 fast enough. And Gate 2 can improve even before a new fab comes online. There is another twist. Better manufacturing efficiency can increase pressure without adding a single new fab. TrendForce expects major suppliers to grow 2026 bit output mainly through process migration because new cleanrooms take time. Shrinking cells and improving yield means more bits per wafer. For CXMT, every yield improvement lowers effective cost and raises sellable output. Technology progress therefore acts like invisible capacity. That efficiency helps a challenger, but it can hurt the economics of the whole industry. That is bullish for CXMT. It can be bearish for DRAM margins. Memory demand usually grows as devices use more capacity, but price per bit tends to fall when supply catches up. If CXMT produces more good DDR5 and LPDDR memory while the incumbents also improve bits per wafer, the industry can move from shortage to surplus quickly. More memory consumption does not guarantee better returns for every memory producer. AI makes that paradox even stranger because it is splitting the memory market into different lanes. AI makes the paradox stronger. HBM and high-capacity server DRAM pull investment toward premium products, while ordinary PCs and phones still need conventional memory. That segmentation gives CXMT a protected lane to scale. But success in that lane can eventually fund movement upward. The near-term competition is not CXMT versus Samsung HBM4. It is CXMT building a cash-generating base beneath the high-end battlefield. If the market is splitting into lanes, who actually owns the best economics in each one? So who captures value today? Samsung still has the broadest defensive position. It leads global DRAM revenue, has deep server relationships, advanced manufacturing, and meaningful HBM exposure. That lets it move capacity toward the most profitable segments when commodity pricing weakens. Scale matters, but product breadth matters more because it gives Samsung somewhere else to send capital when a lower-end market becomes crowded. CXMT cannot copy that stack yet. Its moat comes from a different place. CXMT's advantage is different. It has a large domestic market, strategic policy support, and access to substantial capital. Its prospectus showed state-owned shareholders held 36.29% before the IPO, and the company raised 57.92 billion yuan in Shanghai. Those facts do not guarantee efficient investment, but they reduce one classic constraint on memory challengers: running out of money before the technology and customer base mature. And the most surprising part is what CXMT is doing with pricing while that capital arrives. And this is the newest twist. The China memory story is no longer automatically an undercutting story. Reuters found CXMT exercising pricing power during the shortage, sometimes above South Korean rivals. That could finance expansion rather than destroy margins today. But the cycle matters. If new fabs arrive after shortages ease, the same capacity that created strategic independence can become the supply that pushes prices down. Pricing power can turn into price pressure. That sounds threatening. Now give Samsung the strongest possible rebuttal. Now the strongest argument against this entire thesis. Samsung is still nowhere close to being displaced. It has roughly 5 times CXMT's DRAM revenue share, decades of yield learning, global qualification across major customers, and a much stronger position in HBM. A shortage can make almost any qualified supplier look powerful. The real test comes when buyers have choices again. CXMT may simply be benefiting from the best possible market environment. What specific conditions would make that rebuttal correct? For that counterargument to win, several conditions need to hold. Export controls must keep slowing advanced process progress. New fabs must ramp with weaker yields than headline capacity suggests. International PC and server customers must keep CXMT as a limited secondary source. And when conventional DRAM supply loosens, CXMT must lose pricing power rather than convert it into durable share. Any one of those could materially weaken the disruption case. Those conditions are measurable, which means the thesis can be falsified. So what would falsify the thesis? Watch 3 gates, not headlines. If CXMT stays below roughly 10% global DRAM revenue share, fails to establish repeated non-China design wins, and remains several years behind in advanced server memory through 2027, then the market is still basically a 3-player system. But if share moves into the low teens while qualified DDR5 and server shipments broaden, the structure has genuinely changed. With the test defined, we can separate likely winners from conditional ones. Who wins if this framework is right? The clearest near-term winners are suppliers with scarce advanced memory and strong qualification, especially the HBM leaders, because CXMT pressure is still concentrated below the frontier. Chinese equipment vendors can also benefit as CXMT localizes tools, and large system buyers eventually gain bargaining leverage if a fourth supplier becomes reliable. The key advantage is scarcity plus customer trust, not simply the biggest factory. But several obvious names only win if specific conditions hold. The conditional winners are more interesting. CXMT wins if new capacity becomes qualified output instead of stranded wafers. Samsung wins if it keeps moving mix toward HB-man premium server products faster than commodity competition erodes pricing. PC and phone makers win only if added supply actually reduces memory costs. And Micron benefits if restrictions slow CXMT's high-end progress, but faces more pressure if CXMT becomes a credible global DDR5 alternative. The other side of the matrix is where capital intensity becomes dangerous. The highest-risk players are producers carrying heavy fab costs without durable product differentiation. Watch 4 indicators. 1. CXMT share above 10 to 12% for several quarters strengthens the 4-player thesis. 2. Repeated Tier 1 non-China design wins confirm customer access. 3. Commercial HBM or broad server DDR5 qualification narrows the technology gap. 4. If conventional DRAM prices fall more than 30% while CXMT capacity keeps rising, margin pressure becomes the real story. Now we can answer the title without pretending CXMT has already won. So, is CXMT coming for Samsung? Not for the crown today. Samsung still leads DRAM and remains far stronger at the technological frontier. But CXMT is coming for something the incumbents may value almost as much. The market structure that made DRAM a disciplined 3-company business. An 8% player with expanding fabs, domestic demand, and improving qualification can change pricing behavior long before it becomes number 1. That reframes the key variable from fab announcements to sellable output. That means the key number is not announced wafer capacity. It is qualified sellable bit supply. If CXMT can turn new fabs into high-yield DDR5 and server products, then secure customers beyond China, Samsung faces a structural fourth competitor. If export controls, yield problems, or qualification barriers keep that output trapped below the frontier, the threat remains contained. The next DRAM war is really a race through those three gates. So the real DRAM war is not simply China versus Korea. The headline looks like China versus Korea. The deeper contest is capacity versus qualification, and scale versus product mix. Samsung does not need CXMT to become number one for the economics to change. It only needs a fourth supplier big enough to alter supply discipline. Which gate matters most to you? Wafers, qualified bits, or global customers? Tell me in the comments. And for more evidence-based semiconductor analysis, subscribe to Eagle Research.